Hello everyone, welcome to the 8085 programming series. In this particular session, we'll study a program to find the largest data byte from an array of 10 data bytes starting from 8040. So here is the mnemonics, the code, and on the right side we have the data. So this, I will explain this code, the mnemonics which you have written, and before executing the code we need to store some data. So I have stored 10 data bytes starting from 8040 to 8049. So these are the data, okay, and this particular program, it will actually find the largest data byte. You have, in this case we have 89, so 89 will be stored in register A as well as register D. So what our strategy in this particular code would be like, we will just traverse this particular entire memory space, the array, and we will take the first data byte into register A because comparison cannot be done without A. So the first data byte is moved in register A and we compare it with the second one. If the second one is larger than the first one, we take this data byte into register A. Then this data is compared with the third one. If the third data byte is larger, then we take that into A. If it is not, then we go for the next data byte. So while traversing this array, the larger data byte will be in register A, and finally when we arrive at 8049, the largest data byte will be in register A, and finally we transfer it. Let us understand this code one step by step. I just explain few steps, then you can understand the entire code. So these are the registers. We will be using HL register pair, register A, register C. So with the first instruction LXI H, the data 8040, it gets stored in register H and L. So this LXI is low register pair. Then this also can act as a memory pointer, 80 for 8040. The next instruction is MVIC 0A. So why 0A? Because we have 10 data bytes and 10 in hexadecimal is A. Therefore we have this. And one more thing, here we have the carry and 0 flag. We will be using these two flags. So I have just drawn this two here, shown this carry and 0 flag. Now with the next instruction, we have this move A comma M. So this instruction actually it stores the contents of the memory location to register A. Now this memory is pointed by HL register pair. So HL is pointing at 8040. So data 12 it gets stored in register A. Okay. And of course next instruction is INXH. So INXH, it increments the memory pointer. So this becomes 8040 becomes 8041. And we have this pointer pointing to the next memory location. This becomes 8041. Then with DCRC, the counter, our register C which had 0A, it becomes 09. Okay. Then we check the 0 flag. Okay, this JZ, it checks whether this counter has become 0 or not. Now of course we know it has not become 0. So because it is 09, so 0 flag is reset. Okay, so this condition is not satisfied. Therefore it goes to the next instruction, that is compare M, CMPM. CMPM compares the contents of register A with the contents of memory location pointed by HL. So in our case this is what we have, A contains 12 and the memory pointer contains 15. So these two are compared. Now because 15 is greater than 12, so the next instruction checks the carry flag. So carry is set because the data in memory is greater than the data in A, therefore carry flag is set. Okay. Now the next instruction, jump if carry. Now because this carry is set, so this condition is satisfied, so it will jump to the double star. So double star is this move A comma M. So our strategy that we store the larger data byte in register A. So this is what we do. This 15 gets stored in register A. So A becomes 15. Now we go to the next memory pointer by INXH. So this goes to 8042, and of course this HL becomes 8042. Now we decrement the counter. Okay, DCRC. Now counter is 9, it will become 8, and again it is not 0. So this condition is again false. So 0 flag is not set because C is not 0. Okay. So it won't jump to move D comma A. It will go to the next instruction, that is compare CMPM. Now again the data of register A is compared with the memory location. Okay, this is 05 and this is 15. Now in this case HL the data at the memory is less and the data at memory A is more, so we don't store this 05 into register A. Okay, so now in this case carry flag is actually reset. Okay, so as you can see, carry flag is reset. So this condition JC is not satisfied, so it goes to the next instruction JMP. Now JMP will directly jump to INXH because this 3 star and this 3 star is there, so it goes to INXH instead of move A comma M. So it goes to INXH. So now this goes to 8043, so this becomes 43. Okay, and then we go for DCRC, so this becomes 07, and of course 0 flag is not set. Okay, so if we go through this will continue, and of course whenever data which is more than A is encountered in the memory, that data is stored in A, and this continues until the counter becomes 0. Okay, so this goes after this, this is not satisfied, so this will continue, of course. Okay, it is compared and so on. Okay, and finally when we arrive at 8049, okay, so this becomes counter becomes 0. Okay, and we arrive at 8049, and the data which is in register A would be of course 89 because it is the largest data byte. So this is how this program will function. So we can run this program in any simulator or even on the kit, and we'll get this result with the same data. So thanks for watching.